Okay, so in this video, we're going to start looking at collision detection. I got a little ahead of myself in the last video because in the last video, I already added the colliders, so let's do a quick recap of that. For two objects to have a collision be detected by Unity, both objects need to have a collider of some kind. Now, the reason why I say some kind is there's multiple types of colliders. For 2D environments, there's polygon colliders where it will make an outline around the shape. There are circle colliders. There are box colliders. In the 3D environment, there are sphere colliders, as well as other types of colliders. So since we're in a 3D environment, even though it's emulating a 2D game, since it's in a 3D environment, we're using 3D colliders, and that will also help us with, say we decide to have things coming in along the z-axis. We don't right now, but maybe we will. It lets you proactively prepare for that. So we added a sphere collider to our playable character, and we set it as a trigger. For our pumpkin, we also added a sphere collider set as a trigger. And one thing that I did between videos, I just renamed our energy attack. It was called Particle System. If you just click on the name, you can rename it. I called it Bolt. And this also has a particle system. Excuse me, it also has an orb, a sphere collider that is set to trigger. Okay, so now what we need is the code that actually detects that. So a script needs to be attached to the objects involved with the collision. So we already have a script attached to our pumpkin. It's the pumpkin attack script. So that name is going to become a little bit more inaccurate because it's going to handle more than just pumpkin attack. So that script is already open. And right now all it does is applies velocity. What we want to do is we're going to add a new section outside of start, outside of update, called void on trigger enter, and then collider other. Okay, so much like start and update, on trigger enter will always automatically be checked. But for that to work, you have to make sure you spelled it correctly. You have to use the capital O, T, and E, and the other letters have to be lowercase. If you make even one error with the spelling of this, it will not work. It'll think that it's some entirely different routine. So on trigger enter. So this is part of a script that is attached to the pumpkin. So what we do in here is going to therefore affect the pumpkin. So what we're going to do is first, let's check the name of what we're colliding with. That's what this is doing. This is a way to reference what you're colliding with. So if other.name is equal, and when an object is instantiated, when it's spawned, it will be the name of the object. Okay, it's the name of the prefab with the word clone in parentheses appended to it. So even though the name of the prefab is Bolt, that is what its name will actually show up when it gets spawned. So Bolt with the word clone in parentheses. Okay, so if the object that the script is attached to collides with another object, and the name of that object is Bolt, then we want something to happen. Well, pretty simple. We want to destroy game object. That is, destroy the game object that the script is attached to. Again, it's attached to the pumpkin. Now, that's about all it's going to take to make this work. Now, what's going to happen is the pumpkin is set to destroy, but the bolt is not set to destroy. So we'll run it like this first so you can see the difference. See? Now you might want to create some kind of piercing shot that hits more than one enemy. So you might want that effect. In this case, we don't. Maybe that could be a power-up or a buff. So now what we're going to do, we're going to copy this because it's almost exactly what we want. We'll come to the bolt script, which is also attached, or it's attached to the bolt object. We're just going to paste it right in there. So again, void on trigger enter collider with other, but now we just need to change this so it's the pumpkin. So let's just confirm the name. So it's pumpkin followed by the word clone. And again, destroy game object. In this case, destroy game object is referencing bolt because that's what the script is attached to. See, now they both disappear. So far, so good. So now what we're missing, though, is when they collide, they really should spawn an explosion. They shouldn't just disappear like that. So let's create another particle system. So game object, particle system, and we're not going to get really fancy with this one. This is going to basically just be a placeholder, and then you can always come back and make it look more impressive. So we're going to go to the shape, go ahead and change it to a circle. We're going to rotate it towards the screen. So it looks like the rotation should be 0, 180, 180. Well, negative 180, negative 180. We're going to take that center. I'm going to actually shrink that. You want it to come out from a very small center. Now, the other thing that we need to do is we need that particle system to be, again, on the same Z. It's way far in the distance, so we'll bring it to 0. Now, a particle needs to be much smaller, so let's make that like 0.1. We want there to be much more of them because they're so small now. So let's bump that up to, say, 150. They're moving way too fast. So let's bring that to a start speed of 1. And it's lasting way too long, so let's bring that down to 1. And we don't want it to last very long. So the duration is only going to be like 0.3. I think that particle is a little bit too small, so let's bump it up a bit. And again, this is like sculpting. You're going to tweak this until you feel it looks right. The rate, we can bump that up a little bit more too, make it a little fuller. And now let's just add a little color. So, color over lifetime. And you could have it start at, say, like a light color like yellow and turn red, or do the opposite, whatever you feel looks right. So let's try having it start at like a yellow. So the top is for transparency, the bottom is for color. So you click here to select where on the timeline you're doing this. Click on color, choose your color. So you can see it starts as yellow, changes to white. So now we click here, again click here for the selector, and let's make it like a red. Now right now it's happening evenly across the life of the object. You could actually change that if you wanted to. Like maybe you want it to be yellow longer, you could just click here, set this to the same shade of color, and so it condenses the period of time in which it gets turned to red. So let's do that just so you can see how that's done. So if we click on this, I just want to grab the color. So it's 251, and I'll also just make it a full 255. So it's pure yellow. So 255, 255, 0. So click, say, right here. Click here, and again, use 255, 255. So now what you've done is a few moments ago, it immediately started changing to orange. Now it stays yellow for a longer period of time and doesn't start changing orange until after this part. It's kind of hard to tell because it's so small, but the center of yellow does last longer now. And now that you have this, you could just like drag this over. So like I could do this. And now if you're looking over here, you can see that the yellow is much more predominant. And we can just bring this back. You can change the transparency over time, but that takes really takes some care because sometimes odd things happen with transparency. So we can get into that in a separate tutorial. And if you don't want the particle to just disappear, you can do size over lifetime, right click to create a key, and then just grab the endpoint. That way we don't change the size at first, it doesn't disappear to the very end, and now you can see it getting smaller at the last moment. So looking at the size of this doesn't look quite right, so let's have the life be a little bit longer, and have the start speed be a little bit longer too. We'll increase the max particles just in case we hit it. We shouldn't, because there would be like a dead zone where nothing gets created for a moment. But now we can bump this up a bit more, and that should do it. Like I said, you could get lost in just the sculpting of the particle systems. And now we'll call this one burst. Now, unlike the other objects, this doesn't need it doesn't need a rigid body because it's not going to be velocity. It's just going to explode in place. Nor does it need a collider because this is just going to be spawned. It's not going to actually collide with anything. Now, if you have a complex game where explosions can create more explosions because something brushes up against it, then yeah, you would have a collider at that point. But we're not going that complex. We just want something to spawn when a pumpkin gets destroyed. So we're going to take that, going to drop it down into there, and we're going to delete this. So, as I said, for an object to get spawned, another object needs to be aware of it. So in this case, there's a couple ways you can do it. You can either have the bolt be aware of the burst and have it spawn when it gets destroyed, or you can have the pumpkin be aware and it spawns the burst when it gets destroyed. 6 one way, 1/2 dozen the other. We're just going to have we're actually going to have the pumpkin store it just in case the individual objects will have a burst unique to them. Like maybe something's like metal and it will burst out into like metal filings as opposed to just like a fiery burst. So that's what we're going to do. So we're going to go to pumpkin and we're going to create a transform variable because, as we said, that's how you make one object aware of another. Public transform, and we'll call this burst obj. Again, adding the letters obj so I know it's an object when I see it appear in a list somewhere. We already carved out the area where a collision occurs with the bolt. So we just need to add an extra line in here, and it's the instantiate. So instantiate, this time we're instantiating the burst obj. Where is it being instantiated? It's being instantiated right where the pumpkin is. So we can just do transform dot position. In other words, the location in which the object that the script is attached to. So wherever the object is that the script is attached to, that's what transform.position returns. And then we'll use burst obj's rotation. That should do it if I haven't forgotten anything. So we already detect the collision. We already checked to make sure that it's the bolt it's colliding with. That way we're ruling out other collisions, like collisions with other pumpkins or collisions with a witch. So in addition to destroying the pumpkin, we're also going to instantiate the burst. Now the final step is we go to our pumpkin object, you'll see that new burst variable. We take burst, we put it there, and actually one more thing. Let's go back to burst. We didn't get rid of looping. And let's bump this up actually, which means we can shrink the lifetime. So it looks like this is not lasting long enough. There we go. Not perfect, but you get the idea. And now you can just play around and get that explosion to work the way that you want to. What's important is that you've carved out the section where it occurs, and you have your placeholder object. Now it's just a matter of tweaking that so it looks the way that you want it to look. Maybe it lasts a little bit too long still. As far as once the particle is created, it lasts too long, but maybe you want the particles to be created a little bit longer. So how long the particles are being created versus how long the actual particle lasts. And we'll run this one last time, and that should do it for this video. Yeah, it's good for now. Okay, that should do it for this one.